Hi everyone, I am Dr. Ramananda HS, Professor, Department of Mathematics, St. Joseph Engineering College. I am presenting a small information video about the Fourier series. What is Fourier series? A Fourier series decomposes any periodic function into sum of simple oscillating functions. So what do you mean by periodic function? That we will see now. Oscillating functions are sine and cosine functions. That means to say we are trying to decompose the given function or a given signal into sine and cosine signals. This was invented in 1807 by Joseph Fourier, who lived between 1768 to 1830, and he presented his work in French Academy in 1807 but published his work in 1822, the analytical theory of heat. In 1829, another mathematician called Dirichlet provided rigorous condition when this Fourier series exists for a given function f of x. So we said something about the Fourier periodic functions. What is periodic function? A function f of x is said to be periodic if it satisfies the condition that f of x plus t is f of x for all values of x. Natural periodic functions are sine and cosine, square waves, sawtooth waves and triangular waves. The Fourier series formula is a naught plus summation of an into cos nx plus bn into sin nx, where we have to calculate the constants a naught, an and bn, where a naught is called DC component of the Fourier series, whereas an is called cosine component and bn's are called sine coefficients. And these a naught, an, bn have this formula: a naught equals 1 by 2 pi times integration of f of x between minus pi and pi, whereas an has 1 by pi times integration of function f of x multiplied by cos nx and multiplied by 1 by pi. Similarly, bn is defined. Remember, this expansion is valid for any function of period 2 pi. Now we said something about Dirichlet condition. If a function satisfies these conditions, then only we can find the Fourier series for such function. So what are the Dirichlet condition? First one is the function should be a periodic function, that is f of x plus t should be equal to f of x. The second one is function may have discontinuities or it may be simply a continuous function. Function should not have infinite number of extremums. That means within the given range, function may have only finite minima or maximum, or it may be a constant function. The last fourth condition is we should be able to integrate the function. F of x should be an integrable function. There is one more thing which will help us to calculate the Fourier series expansion called even and odd function properties of the function. If we come to know that the function f of x is even, then we need not calculate bn. Whereas if we come to know that the function is odd function, we can simply calculate bn. We need not calculate an and an. Naturally, an and a naught become 0 if the function is odd function. So what do you mean by even function? If a function satisfies the condition that f of minus x equals f of x, then we call it as even function. If f of minus x is minus of f of x, we call the function as odd function. Take an example: cos of minus theta is cos theta, hence cos is an even function. You take x square, minus of x square and x square both are same, hence x square is an even function. Similarly, if we take sin theta as f of x, sin of minus theta is minus of sin theta, hence it becomes odd function. Any odd power of x becomes an odd function. Let us take the Fourier series expansion of a particular function called square wave function, which is defined as minus 1 between minus pi and 0, 1 from 0 to pi. Okay, the Fourier series expansion of this contains only sine terms just because it is an odd function. The answer for this is, that means the Fourier series, after finding this Bn, we will get the answer as 1 by 4 by pi times sin x, sin 3x by 3, sin 5x by 5, sin 7x by 7, etc. Now, what are the applications of this Fourier series? One is in signal processing, analyzing and filtering signals, music and acoustics, understanding harmonics and timbre in musical instruments, heat transfer, solving the partial differential equations, and in mechanical engineering to study the vibrations and structural dynamics. So in this talk, I just touched upon the following things: Fourier series and decomposition of given function into sine and cosine series, how we can calculate the coefficients a0, an and bn, what are the conditions for convergency of this means Dirichlet conditions for Fourier series, even and odd property of functions, and some applications of Fourier series. Thank you.